Answers are here for part A and B, and I give a solution for part B. Pause and copy if you weren't successful in getting this vector here. And we'll move on to a distance question. So using projections to find distance. I'll pause, copy. Okay, so we're going to do a lot of different distance problems, and what we have to do is, draw a picture and think about what projection will help us. Okay, so picture is not given. And what else? I typically won't say shortest. You'll usually not have this. You'll be expected to find the shortest distance when I say just distance. And I probably won't say the line. I'll expect you to understand what object that is. Okay, so this one here, what am I going to do? I'm going to find a projection that will help me find D. D is what I want. So I'm going to draw the vector that goes from 0, 2 to the point A, and we'll call that vector V. And what is V? V is, well, you can go from this point here. Oh, that's not good. You can go from the point 0, 2, and you go backwards down to the origin. So you could say negative 0, 2 plus the vector 0a. Which is formed from this point is 5, 4. So what do we get there? We get 5 and 2. Now if I clear up my picture here, what do I want? It looks like I want the projection of V onto this line, right? Well, not quite the projection, I want this perpendicular, right? But I'll need the projection first. So I want to take the projection of V onto this line L, but we're not going to project onto the line. We're going to project onto the direction vector for the line. So this is the vector 3, minus 1. So we'll do that next. The projection onto 3, minus 1 of V is, you dot these two vectors, right? 3, negative 1 dot V, which is 5, 2, all over the dot of the vector you're projecting onto in the direction of the vector you're projecting onto. So what do we get? We get 15 minus 2 is 13. 9 plus 1 is 10. 3, negative 1. Okay, so what I've found here is this projection, this vector here. Okay, so this calculation here gives me the vector in green right here. That's not what I want. I want D, which is the length of the perpendicular. 3, -1v, which is the length of v minus projection 3 minus 1 v. And v was what, 5.2 minus 13/10, 3 -1. And we get something unpleasant, right? We get 5 minus 39/10. 2 plus 13/10. Oh, forgot my length signs. And then what's that? (11/10), 33/10. Now, before I find the length, I'm going to want to factor out 11/10. Makes this a lot nicer. Otherwise, you're going to find yourself squaring 33, which you don't want to do. And 11/10, root 10. Okay, pause a copy if you haven't done so already. And we'll move on. Next example. Same idea, but you have it happening in R3. You get a point and a line. And what I'll do is draw a picture that is not to be taken literally. So I'll have an L. I'm not trying to figure out exactly what this line looks like. I'm just trying to draw a picture that will help me think about this scenario. Okay, so we got a line. Let's put the origin down here. And let's put, we'll call the point A up there. So I'm going to draw a picture that's very similar to the one I just had. Now, 113 is a vector that is on the line. Let's put it here. Should I be naming things? No, let's just go 1, 1, 3 here. And then let's say the 301 is a direction vector for L. Let's say it goes like this. Now, what do I want? What do I want? Well, I want the distance between A and the line. Call it D. So I will interpret that as being some perpendicular. So like before, I'll call this V. And I will say V. V, how can I obtain V? I can go backwards on 113 to get from this point to this point. And so that's minus 113. And then plus the vector 0, A. which is just 3, 1, 2 here. So that gives me 2, 0, minus 1. Now, as before, D is going to be the length of perpendicular. I'm projecting the red vector. If you want, you can imagine the red vector also sitting down here. So V. This is also D down here. So I want to I want to look at this triangle and find the perp, which is going to give me D over here. So for this perpendicular, 3, 0, 1 is my subscript here. It's kind of awkward as a subscript. And the vector V is my thing I'm projecting. 2, 0, negative 1. So what do we get? Using the formula for perp, which I memorize, minus the projection. 3, 0, 1, 2, 0, negative 1. So now I'm just calculating. Dot product gives me 6 minus 1 over 9 plus 1 in the direction of 3, 0, 1. Hope I don't make a mistake. I hope I don't make a mistake. So I get 5 over 10 half minus half. 3 over 2, 0, 1 over 2. Hope I don't make a mistake. Let's double check. 5 over 10 is a half. Yes. Okay. 2 minus 3 halves is 1 half. 0 minus 0 is 0. Negative 3 halves. Now I'll sneak a peek at my answer. Yep. So far, so good. Remember to factor out the half. Otherwise, this becomes even more unpleasant. Half root 1 plus 9, which is root 10 over 2.